Hello and welcome to an algebra tutorial video learning about solving linear equations. In this video we're going to solve multi-step linear equations, which means it'll take 2, 3, 4 steps and they get more complicated. But we're trying to take this inequality that we have here. We got 3x plus 9 all divided by 4. That's less than 2/3 times, in parentheses, 8 minus x. And what I want to do is take all of that and figure out, well, what numbers can x be that make this inequality true? Again, as we're working with inequalities, there's a whole range of solutions that we're trying to find and represent, and so we got to figure that out. Okay, so we solve them a lot like we do with equations. Do things to both sides. We're working to isolate that variable. The only thing we need to be careful of is whenever we multiply or divide by a negative number, we have to reverse the inequality. All right, so let's go solve this thing out. Let's start going through step by step. So I wanted to do one with fractions because a lot of times I find that fractions just tend to be a tripping points for students. I like to give a lot of good examples with fractions in it. So here we've got a fraction with fourths on the left side and thirds on the right side. So one way to actually approach fractions like this is to think about, okay, what can I multiply both sides of the equation by so that I'm not dealing with fractions anymore? Again, fraction is just a way of dividing into smaller pieces, some part of a whole, right? So if I make both sides bigger, eventually I'm dealing with all whole numbers. So here I've got division by 4 and I got division by 3. Well, a factor of both 4, a multiple of both 4 and 3 is going to be 12. So if I multiply both sides of the equation by 12, what'll end up happening is that I will no longer have those fractions. So let's do that. We're going to multiply both sides by 12. That's what I've got written in there. And we're going to need to do some distributing and simplifying. And I'll go through it slowly to make sure you understand what's happening here. So I'm taking 3x plus 9, and I'm going to put parentheses around that to see that that's one whole group. And currently all of that is being divided by 4. Well, when I multiply that by 12, I can rewrite all of that in this way. I still have 3x plus 9. But I can think about multiplying that by 12 and then division by 4 just like this. Well, that's easy to see that 12 divided by 4 simplifies to 3. So now I have just 3 times 3x plus 9. Notice I haven't done anything inside the parentheses. I'm not distributing this 12 into the parentheses. It's easier to deal with that 12 and the division by 4. Both of those things are happening to the entire parentheses, and so I can simplify both those together first and then do the distribution at the end. So that would be the next step. But let's take a look at the right side now and simplify some things there. So this 12, notice I also have the whole fraction 2/3. All of that is happening in front of the parentheses. So one way I can rewrite on the right side is I have 8 minus x. It's being multiplied by 2/3. Let's go ahead and put that 2/3 at the end. It's okay to, doesn't matter the order in which I multiply things. And then I'm multiplying that by 12. And I'll rewrite that as 12 over 1, and it should become really obvious now that we can just multiply our fractions together and simplify things out. So 12 times 2 gives me 24. 1 times 3 gives me 3. I still have 8 minus x. And let's go to the next step. 24 divided by 3 just turns into 8. So now we have 8 minus x times 8. And I'm going to go ahead and leave that 3 there for now. 3 times 3x plus 9. Okay, so all we've done so far is I multiplied both sides by 12. And then we simplified things out. And now I have an inequality that has no fractions in it. So it becomes a whole lot easier to solve from this point on. All right, so let's go ahead and distribute the 3. So we got 3 times 3x gives me 9x plus 27 is less than, and let's distribute the 8. 8 times 8 is 64 minus 8x. All right, now I've got an inequality with variables on both sides. So I want to get one variable on one side and isolate things around. So I'm going to go ahead and add 8x to both sides. And I'm going to go ahead and subtract 27 from both sides. I'm going to move the constant over to the other side as well too. So what I have is 9x plus 8x gives me 17x. The 27 minus 27, those go to 0. And then 64 minus 27 turns into 40, 30, 37. All right, and notice at this point, I've just been simplifying things. I haven't multiplied anything or divided anything on both sides by a negative, so my inequality has stayed the same. Make sure you're writing that inequality. Lots of times I'll see students, they'll do a big long problem, they'll forget to write the inequality, and all of a sudden they'll turn it into an equal sign. So they've changed the whole problem, and it kind of really throws off their whole answer. So no, we still got now 17 times some number x is less than 37. So now I've just got one more step to follow out through there. Let's divide, switch colors here. Let's divide both sides by 17. And we see that x is a number that has to be less than 37 divided by 17. 17 goes into 37 two times. 17 times 2 is 34, so I can rewrite that as x is less than 2. 17 goes into 37 two times, but there's a remainder of 3, so it's 3/17. All right, there's my fraction in exact form. If I'm dealing with the fractions correctly and I'm handling my fraction arithmetic, then I can get an exact answer like this. So this is a problem. Definitely don't round it to the nearest decimal. Don't turn it into a decimal and approximate it, because you may get an answer that's close, but it won't be exact. So there you go. Hopefully that's a helpful example for you in solving multi-step linear inequalities that have fractions in them.